Good afternoon or good evening, depending on where you are. I'm Dr. Jane Waite. I'm from Aston University in the UK, and I'm a researcher with a really keen interest in behavioural phenotype research. So it's an absolute pleasure to be here today to chair this symposium on novel approaches to behavioural phenotype research in genetic syndromes associated with intellectual disability. We're going to hear from 5 speakers, all of whom have taken a different methodological approach in their research. So the first speaker will be Dr. Stacey Bissell from the University of Birmingham. Stacey is going to be presenting her research on the behavioural phenotype of SAPB2 associated syndrome. Stacey's taken a cross-syndrome approach using questionnaire methodology, and she'll be comparing SAPB2 associated syndrome with Angelman syndrome and autism. The second presentation will be by Dr. Georgie Agar. Georgie Agar will be looking at overnight parent-child proximity in relation to poor sleep in children with Angelman and Smith-Magenis syndromes. And Georgie's research is particularly interesting as she'll be talking about the use of radio frequency identification technology in her approach to answering this question. The third presentation will be by Dr. Hayley Crawford from the University of Warwick. Hayley is looking at the variation in behaviour in Fragile X syndrome, and she's approaching this by looking at the genotype of Fragile X. And then we have 2 presentations from the University of Surrey to bring the symposium to a close. The first presentation is by Dr. Joanna, who is presenting data on eye tracking in Fragile X syndrome, and she's particularly interested in gaze following in Fragile X syndrome, so we'll be presenting those data. And finally, Dr. Katherine Ellis will be presenting data on over-imitation in Cornelia-de-Lange and Fragile X syndrome. And Kat has applied novel behavioural assessments in her research. Finally, to wrap up this symposium, we'll hear from Professor Jane Roberts from the University of South Carolina. Jane is extremely experienced in the behavioural outcomes associated with rare genetic syndromes such as Fragile X syndrome and neurodevelopmental disorders such as autism. And she's particularly interested in the biological mechanisms that lead to these behavioural outcomes. It's an absolute pleasure to have Jane join us and to look at the themes that cut across these 5 presentations. So I'll now hand over to Stacey Bissell, who will present her work on SAPB2 associated syndrome.
Hi, my name is Stacey Bissell and I'm a research fellow from the University of Birmingham. Today I will be presenting on a novel approach to data analysis that we adopted when investigating the behavioural phenotype of SAPB2 associated syndrome. SAPB2 associated syndrome is caused by genetic variation to the 2q33.1 gene, and its characteristics are summarised by a SAPB2 diagnostic acronym. Intellectual disability and delayed language acquisition are considered the hallmark characteristics of this syndrome, with 42% of individuals evidencing completely absent speech. The largest behavioural study to date adopts quite broad terminology to describe behaviours in SAPB2, even though 55% of individuals are reported to evidence behavioural issues. If we take these broad behavioural descriptions of SAPB2, there is a strong argument for adopting a cross-syndrome comparative approach to better define these behaviours in this new syndrome group. A happy disposition and delayed language acquisition are considered the hallmark characteristics of Angelman syndrome, and in fact, a differential diagnosis of Angelman syndrome has to be frequently ruled out in SAPB2 in early infancy. Obsessive tendencies and autistic characteristics occur in several genetic syndrome groups, but there are often qualitative differences in the autism presentation when compared to non-syndromal autism. Cross-syndrome research has never been conducted in SAPB2, but it would be hugely beneficial to determine how the SAPB2 behavioural phenotype may align or differ to these 2 associated well-delineated groups of Angelman syndrome and non-syndromal autism. So in this study, our SAPB2 group were matched on age and level of ability to these groups. Informant report measures of behaviour were completed, but in the interest of time, I will be focusing today on the repetitive behaviour questionnaire and the social communication questionnaire as our measures of autism. So these measures are freely available on the FIND website and are specifically developed for severe intellectual disability populations. So 63 participants were matched according to chronological age and ability, but there were other demographic differences between groups that should be held in mind. So as expected, there were more males in the autism group and fewer individuals with expressive speech in the Angelman group. There were also fewer individuals with Angelman syndrome who were fully mobile compared to the SAPB2 and non-syndromal autism groups. Subscale analysis of the RBQ revealed differences on the non-verbal subscales. So these are the first 3 subscales on the graph. Please note the last 2 subscales are verbal subscales, and therefore the Angelman group were not included in these analyses, but there were no significant differences between SAPB2 and autism relating to restricted preferences and repetitive speech. In relation to stereotype behaviour, the SAPB2 group obtained lower average scores than individuals with autism. On the compulsive behaviour and insistence on sameness subscales, both SAPB2 and autism obtained higher scores than the Angelman group. Now, if we look at the SCQ subscales, the SAPB2 group evidenced lower subscale scores than the autism group across all subscales, and there were no significant differences between the SAPB2 and Angelman syndrome groups. So in conclusion, at subscale level, there were no significant differences on the verbal RBQ subscales between SAPB2 and autism. Across all SCQ subscales and the stereotype behaviour RBQ subscale, the SAPB2 group obtained lower average scores relative to the autism group. So this would suggest a degree of difference in relation to the autism profile, namely lesser impairment in SAPB2. However, on the RBQ compulsive behaviour and insistence on sameness subscales, the SAPB2 group obtained higher subscale scores than the Angelman group, but convergent scores with the non-syndromal autism group. So just to say that all differences were significant at 0.01, and also here we are reporting Bayes factor analyses which adopt a weighted probability approach for accepting or rejecting the null hypothesis. However, are these subscale analyses enough to confidently infer that the SAPB2 group do not evidence autism characteristics as much as the non-syndromal autism group? So clinically, does this mean we shouldn't be concerned by the autism profile in SAPB2 based on these SCQ findings? Well, no. So if we take the SCQ at item level, as there are psychometric norms for the SCQ, and take the reciprocal social interaction domain, the subscale analyses would have us believe that fewer individuals with SAPB2 would score on individual items compared to individuals with autism. When in fact, on these 4 items in the domain, more individuals with SAPB2 score on these items than individuals with autism, which we wouldn't really have uncovered if we had stayed at subscale level. On 2 items relating to play, fewer individuals with SAPB2 score compared to both autism, but also Angelman syndrome. So there may actually be something about play-based social interactions in SAPB2 associated syndrome that warrants further investigation. So in conclusion, there is clinical utility in adopting a novel approach to exploring group comparisons beyond subscale level to parse out these fine-grained differences in behaviour. For a newly defined syndrome like SAPB2, the value is in elucidating which existing autism interventions may or may not be effective. Future research should aim to clarify whether these non-verbal social difficulties in SAPB2 are rooted in an autism presentation, or whether they in fact reflect underlying difficulties in social anxiety or an absent social motivation. So thank you for your time, and thank you to the SAPB2 associated syndrome community for their involvement and continued support of our research.
in today's symposium, we're thinking about novel approaches to assessment in behavioural phenotypes. And I'm going to talk to you about some work that I've done in two rare syndromes, Angelman syndrome and Smith-Magenis syndrome. Now, the reason I'm interested in these syndromes is because the prevalence of sleep difficulties is really very high in these. So this is from my recent meta-analysis. You can see highlighted in blue and purple the Angelman and Smith-Magenis groups. And really what you're seeing here is just an elevated rate of lots of different kinds of sleep disorders, but particularly problems with insomnia. So settling to sleep and kind of waking at the wrong times, or waking and not being able to go back to sleep. Now, there are lots of aspects of the phenotypes of both syndromes that could kind of feed into these sleep problems. I'm just going to focus on the social profile today. So the idea that individuals with these syndromes have a preference for adult rather than peer interaction, and in the SMS group that's for a particular caregiver as well. Now, the reason I'm interested in these kind of the sleep and sociability aspect is because at least in kind of typical development, and in children, insomnia is really understood from a behavioural perspective. So it's often treated with kind of sleep management and sleep hygiene techniques. So the idea that children need to have kind of the same conditions when they wake as they had when they settled. So if they have a parent with them at settling, it might be difficult for them to self-soothe without a parent if they woke up. They need to have a bedtime routine that cues sleep, etc. So that's kind of the associative learning or sleep hygiene kind of aspect. And then, of course, we can apply our operant model. So the ABC model that applies to challenging behaviour can apply to challenging behaviour that occurs at waking, or other kind of signalling behaviours like crying or going to get a caregiver can all become reinforced over time by that caregiver attending to the child, particularly if that child has a preference to be with that caregiver. And there's a few ways we could study this. So quite a simple way is to just ask parents about interactions overnight. And if you're doing a sleep study, chances are your parents already doing a sleep diary, so they can sort of tell you about that. But the difficulty with that is if parents are sleep deprived, which often they are in these studies, it might be quite difficult for them to remember what happened at the waking at 2 a.m. versus the waking that happened at 3 a.m, who was there, how long the interaction went on for, and so on and so on. So it can help to have an objective measure. In the kind of broader TD infancy literature, there's been a lot of video somnography studies, and we've also conducted one in these two syndrome groups. And this is brilliant. It's really helpful. You put the camera in the child's bedroom and you can see what's going on, up until the point at which the child leaves their bedroom to go and find a caregiver and have an interaction, which you then have no insight into. So as part of my PhD, I wanted to develop another way of looking at this, an objective and kind of dynamic measure that would move around with the parents and children as they were having interactions. And so I used radio frequency identification technology for this. It's quite similar to Bluetooth in that sensors will exchange a kind of packet of information when they're within a certain range of each other. So this is a sensor here, so it's quite small and can be disguised in this kind of watch casing, similar to an ActiWatch. And what we did was ask a child and both their parents who were taking part, or if they only had, if they were a single parent family, just that one parent, to wear these watches overnight, and we would look at the interactions between them. And we didn't look at the interactions between the two caregivers within themselves. So it was just about the child and how often they interacted with each parent. And so our research questions were really around what do these interactions look like and what does that mean for the behavioural model that I've sort of outlined briefly. So we had 19 children across syndrome groups, and they wore both watches at the same time as part of this kind of broader assessment. And we'd previously developed in the video somnography study these standardised definitions of sleep and wake. So the first thing we were interested in was how many wakings actually resulted in interaction. And you can see the percentages here. It's actually quite low considering the kind of the phenotypic preferences for sociability and interaction that we know about in these groups. And also, importantly for the associative kind of aspect, it's not that parents who were present with their children when they fell asleep, they weren't more likely to be with their child when they woke up. So there doesn't seem to be this kind of problematic learned associations with parents being there either. So what was going on? Well, what we were able to look at was detailed graphs of all of the data together for each child. So here's an example here. This is one night of data. You can see time along the x-axis, where you see these grey bars here. That's when actigraphy considers the child to be awake. And then the green and the blue here are the sort of the sensor interactions between this child, and the green is their mother and the blue is their father. And the taller the spikes are, the closer they are together in space. And so we also noted obviously the time the child fell asleep and woke up according to actigraphy, so the dashed and dotted lines there. And we were looking at kind of interactions that occurred really between those two time points. And that was one night zoomed in. We looked at the whole of the study week where we could for each child, and then categorised them according to these categories. So the first one was for checkers. So you've already seen a checker, ANG17. You can see here that there's kind of bursts of interaction with both caregivers happening throughout the night, often following a period of waking. But it wasn't always when the child was awake. So often parents were going in to check even when their child was asleep. And that kind of suggests some kind of concerns around medical equipment and comfort and things like that. The mean number of checks per night was 15, and they were happening roughly hourly. So this is really an extreme amount of sleep deprivation for parents. Another kind of classification that we saw was co-sleeping, and you can see here these bars running in parallel, extended bars, and they basically suggest the child is co-sleeping with both parents, either from the start of the sleep period or following a waking, as you can see in SMS4. And these only lasted, they were about 4 hours, so that wasn't the whole sleep period. And really this emerged as kind of a safety behaviour. Parents would say that it only happened one night of the study week when they just felt they needed to keep their child safe. And so possible interventions might involve having cameras in children's bedrooms or other ways of monitoring them so that we can make sure we're keeping these children safe overnight. And that's something we're working towards in the SMS group. And then finally, I think possibly the most interesting group is this no proximity group. So you can see here they had lots, well not lots, but they had interactions with their caregivers in the kind of normal bedtime routine. But then after they fell asleep, caregivers didn't come back in, even though the waking in these groups was still significant. So this child on average was awake for 3 hours every night, and yet the parent never went in. So from our kind of behavioural perspective, the parent is doing all the right things. They've got good sleep hygiene, and they're not going in and attending to each child's waking, and yet the child is still waking up. And so we need to start to think beyond the behavioural model and consider perhaps biological underpinnings. So we need to look at the child's circadian rhythm, and we can think about epilepsy, and we can also be thinking about pain. And this is something I identified in the video coding paper as well. So it's really important to consider that not all sleep problems in these groups are behavioural, and hopefully I've been able to kind of point you towards a couple of different underlying mechanisms that are worth studying in these groups to kind of find out if that's what's underpinning poor sleep. And hopefully I've also been able to highlight the variable profile of overnight parent-child proximity and caregiver experiences even within these same syndrome groups. So thank you so much for listening. Thanks to my funders and particularly to the children and families that took part. Thank you.
Hi, I'm Dr. Hayley Crawford, and I'm going to present 2 studies that increase our understanding of self-injurious behaviour and other clinically relevant behaviours in males with Fragile X syndrome. So existing research shows that over half of males with Fragile X syndrome show some form of self-injurious behaviour during their lifetime. Also, approximately 50% display aggressive behaviour. Despite these behaviours being common in Fragile X syndrome, little is known about risk markers and also how they change over the medium to long term. So the 2 studies I'll be presenting today answer 3 research questions. First, how do these behaviours change over time? Second, what are the behavioural risk markers for their persistence? And third, what are the genetic risk markers for their presence? So the challenging behaviour questionnaire was completed by parents of 79 males with Fragile X syndrome at 3 time points across 8 years, so that we could look at change over this time period. And to understand more about the behavioural risk markers for self-injurious and aggressive behaviour, we looked at characteristics associated with 2 of the most common comorbid diagnoses in Fragile X, that's ADHD and autism spectrum disorder. So we used the activity questionnaire to look at characteristics associated with ADHD, namely overactivity and impulsivity. And we used the social communication questionnaire to look at characteristics associated with ASD, that is restricted repetitive behaviour and social communication. So in terms of how these behaviours change over time, we found that 77% of people who displayed self-injurious behaviour at time 1 persisted to show that behaviour at time 3, 8 years later. And we found that 69% of people who displayed aggressive behaviour at time 1 persisted to show that behaviour 8 years later at time 3. So then to identify behavioural risk markers, we split the sample into 3 groups, those showing persistent self-injury at each of the 3 time points, those showing transient self-injury at least one of the time points, and those showing absent self-injury at all 3 time points. So we then compared the time 1 subscale scores from the SCQ and the activity questionnaire across these subgroups. And we found that overactivity, impulsivity and social communication scores were similar across the 3 subgroups, but there was a significant difference in repetitive behaviour, with lower repetitive behaviour at time 1 in those with absent self-injurious behaviour compared to those with transient or persistent self-injury. We then conducted a binary logistic regression with data from those with either persistent or absent self-injury, and we found that early repetitive behaviour predicted persistent self-injurious behaviour, such that increasing repetitive behaviour scores were associated with an increased likelihood of exhibiting persistent self-injury, and this had an odds ratio of 1.5. So we used the same approach for aggressive behaviour, and we found a significant difference in chronological age, impulsivity and overactivity between the 3 subgroups. So participants with persistent aggressive behaviour were significantly younger than those with transient or absent aggressive behaviour. And we also found that time 1 impulsivity and overactivity was lower in those with absent compared to transient or persistent aggressive behaviour. So when we entered these factors into the binary logistic regression, it was only impulsivity that predicted persistent aggressive behaviour, and this had an odds ratio of 1.2. So despite self-injurious and other behaviours being common in Fragile X syndrome, we do see individual within disorder variability. So we wanted to further understanding of this phenotypic variability by identifying potential genetic risk markers. So we looked at SNPs, or single nucleotide polymorphisms, the most common type of genetic variation when a single nucleotide differs across different people. So most SNPs have been shown to have no effect on health or development, but some have been shown to be very important to human health and behaviour. So a couple of studies in Fragile X syndrome alone have identified that the 5-HTT-LPR genotype is associated with aggressive and stereotype behaviour, and also with improvements in clinical measures when children receive medication versus placebo. So in the general population, genotype-phenotype associations are often investigated with genome-wide association studies, but statistical modelling has identified that tens of thousands of participants are required to answer even simple questions of the data. And this isn't possible to achieve in rare syndromes. So an alternative approach, and one that we've taken here, is to select SNPs a priori on a theoretical basis with regard to their function and previous findings, as evidence suggests that many SNPs directly or indirectly affect neurotransmitter function and other neural mechanisms that play a role in phenotypic expression. So we identified 3 candidate genes to investigate based on literature identifying them as playing a role in clinically relevant behaviours, similar to those that we're interested in Fragile X syndrome. So this is 5-HTT-LPR associated with serotonin, MAOA and COMT associated with dopamine. And we compared the different genotypes on measures of behaviours at challenge, autistic characteristics, ADHD, affect and repetitive behaviour. So these measures were all completed by parents or carers of 64 males with Fragile X syndrome with an average age of 18 years. And we found no association with between any of the measures with 5-HTT-LPR or MAOA, but we did find associations between the COMT genotype and some of these behaviours. So specifically compared to the AG and GG COMT genotype, the AA genotype was associated with lower property destruction and lower stereotype behaviour as measured by the Challenging Behaviour Questionnaire. We also found that the AA genotype was associated with higher levels of interest and pleasure than the AG genotype. And we found that the AA genotype was associated with less stereotype behaviour and compulsive behaviour than the other 2 genotypes on the repetitive behaviour questionnaire. So this shows us that the AA genotype is associated with greater interest and pleasure and with reduced risk for property destruction, stereotype behaviour and compulsive behaviour. So taken together, these findings highlight the persistent nature of self-injurious and aggressive behaviour, underlining need to develop early interventions. We also found early risk markers for these behaviours, which facilitates this early intervention by identifying those at highest risk. But importantly, these risk markers were different for self-injury and aggressive behaviour. pointing to the need to consider these behaviours separately rather than lumping them together under an umbrella term of behaviours at challenge. We also identified additional genetic risk in understanding the neural and genetic mechanisms, so beyond the Fragile X mutation, that contribute to the phenotypic variability in Fragile X syndrome. So thank you for listening, and to the participants, funders and collaborators of this work.
Hello, my name is Jo Moss. I'm a lecturer at the University of Surrey, and today I'm talking to you about our preliminary findings from a study of gaze following in individuals with Fragile X syndrome. Research has shown that individuals with genetic syndromes associated with intellectual disability are at increased risk of showing autism characteristics. Fragile X syndrome is the most common genetic cause of autism. And according to this meta-analysis carried out by Caroline Richards, individuals with Fragile X syndrome are 15 times more likely than neurotypical individuals to show autism characteristics. And this translates to a prevalence rate of around 25%. We also know from the research literature that atypicalities in the presentation of autism characteristics is very common in individuals with genetic syndromes. In Fragile X syndrome, there is a general consensus that repetitive behaviour is the most prominent area of overlap with non-syndromal autism, but there may be some subtle differences in relation to the nature of social communication difficulties. The work that I'm talking to you about today was carried out as part of a larger programme of research in which we're interested in whether a typical presentation of autism characteristics is reflected in differences in underlying social cognitive features relative to individuals with non-syndromal autism. And in particular, we're interested in whether we can identify syndrome-specific pathways that underlie and differentiate the syndrome-specific presentations of autism that we observe behaviourally. In this talk, I'm presenting preliminary findings from a study in which we've used eye tracking to evaluate whether children with Fragile X syndrome show differences in responses to shifts in eye gaze compared to neurotypical and autistic children. Data collection is ongoing, and these are our participant groups to date. We have individuals with Fragile X syndrome, autistic children and neurotypical children who are different in regard to their chronological age, such that the Fragile X syndrome group is significantly older than the autistic children and neurotypical children. In terms of receptive language skills, the three groups are roughly similar and well matched. And in relation to adaptive behaviour skills and severity of autism characteristics, individuals with Fragile X syndrome and our autistic children do not differ significantly. So the task that we used is a passive viewing paradigm. It's entirely non-verbal, and this means it's highly accessible and widely accessible. It's based on a paradigm developed by Senju and Sisbra in 2008, in which participants are presented with videos of an individual first looking directly at them and then shifting their gaze towards one of two objects in front of them. And here's an example video. And we're interested in two elements of this video. So we're looking at participant gaze patterns during phase 1, the direct looking phase, and also in phase 3, so whether participants followed the directional cue to look at the congruent object. We've adapted the paradigm and extended it to add two further conditions. So we have a social condition, which is the video I just showed you. And then we've replicated the video, but with a cartoon face. And then we have a non-social condition where we have a ball which makes a similar movement and redirection towards the objects in front of it. So our first question was, do individuals with Fragile X syndrome show atypical patterns of gaze? The graphs here show mean duration fixation across the three conditions of the social condition, cartoon and non-social condition. And the findings demonstrate that individuals with Fragile X syndrome and autistic children look significantly less towards the central cues, the face as a whole and the eye region, relative to neurotypical children. So reduced looking time to both the face and the eyes. Our second question was whether individuals with Fragile X syndrome followed the directional gaze cues. This graph shows the likelihood of first fixation to the correct object or the congruent object. And our findings show that generally individuals with Fragile X syndrome follow these cues less often. And this was significant in both the cartoon and non-social conditions, but also evident in the social condition, although that didn't quite reach significance. Autistic children were just as likely as neurotypical children to follow the directional cues to look at the target object. And our final question relates to whether individuals with Fragile X syndrome showed a preference for social or non-social directional gaze cues. The graph here shows differential looking time to the congruent object within each group and contrasts the looking time across the conditions of social, cartoon and non-social stimuli. The graph shows that in individuals with Fragile X syndrome and in the neurotypical children, when they did follow the gaze cues, their attention was better directed by the social relative to the non-social cues, whereas autistic children didn't show this preference for social cues and tended to follow the social, cartoon and non-social stimuli to a similar degree. To consider the findings then in the context of our model, our preliminary analysis suggests that individuals with Fragile X syndrome show reduced attention to faces and eyes and reduced attention to directional gaze cues. When individuals with Fragile X syndrome do follow directional gaze cues, they show a preference for social cues in the same way as neurotypical children. And so the reduced attention to directional gaze cues may be mediated by a more general deficit in attention, and that we know that that's highly characteristic of individuals with Fragile X syndrome. The findings from Fragile X syndrome are distinct from the pattern of findings in the autistic group, who do follow directional cues and don't distinguish between social and non-social cues in the same way as neurotypical children and individuals with Fragile X. From previous literature, we know that anxiety also has a role to play in relation to both attention to faces and eyes and in relation to the presentation of autistic traits in individuals with Fragile X syndrome. So it's likely to be an important part of the model too, and something to consider in future research. And finally, I just want to thank all the participants and their families who took part in this study. We couldn't do this work without you, and we're really appreciative of our funders and collaborators. Thank you.
Hi, my name is Katherine Ellis and I am a researcher at the University of Surrey, and I'm going to be reporting on data looking at over-imitation in CDLS and Fragile X syndromes. So these are two genetic syndromes with heightened risk of showing high levels of autistic traits, but they're interesting because they show distinct profiles of these traits compared to one another and non-syndromic autism. So those with CDLS are characterised by greater communication difficulties, whereas those with Fragile X syndrome show a more even profile, but at lower levels compared to non-syndromic autism. So this study is part of a broader project looking at the variability in social cognition and considering how this might contribute to these different profiles as described previously by Jo Moss. And I'm going to be reporting data on imitation, which is a really important early developmental skill that's central to developing social interaction skills and social understanding of others through its powerful social learning mechanisms. It is also a core deficit often observed in autistic children as well. We used an over-imitation paradigm, which involves showing a demonstration of how to achieve a goal, so taking an object out of a box, but including an irrational action not relevant to the goal, such as this. And we would demonstrate and then pass it over to participants and tell them to get the object out as quickly as they can. And we would want to observe whether or not they over-imitated without being prompted to do so. And there's good evidence to show that typically developing children show high levels of over-imitation, and that this is something that occurs across the age span, so from infancy up until sort of adolescence as well, which makes it an appropriate imitation paradigm to do with a range of participants with genetic syndromes across a range of ages, considering the rarity of these syndromes, where in order to get sample sizes, we might have to have a bit more older and variable age ranges of participants. It serves a social affiliation and social learning function and is driven by social motivation, of which evidence comes from findings indicating that autistic children show lower levels of over-imitation relative to typically developing children and children with Williams syndrome, which is a group characterised by hypersociability. So the aim of this study was to investigate and compare over-imitation in children with CDLS and Fragile X between one another and comparison groups of autistic and typically developing children. So this is a preliminary sample as data collection is ongoing. The groups were comparable on level of receptive language ability, and the clinical groups were also comparable on level of autistic traits as measured by the social responsiveness scale. Overall, there were 5 over-imitation tasks. And after running through these tasks, children took part in a rationality discrimination task as well, indicating whether an action was sensible or silly, to see whether they could distinguish between these tasks and what the purpose might be. They also took part in a memory task, a visuospatial memory task, just checking whether they could remember 3 item sequences to determine perhaps if they're not over-imitating, is it because of this difficulty with memory? So preliminary results indicate that a higher frequency of typically developing children over-imitated in at least one of the trials compared to the frequency of autistic children who did so. There were no other significant differences, but I do think it's interesting sort of the level of consistency across the Fragile X group of participants who do show some level of over-imitation. It's quite high. We then compared the number of trials, the total number of trials that children over-imitated in across the groups, and found no evidence of differences across the broader sample, but out of those who over-imitated at least once, we found that the typically developing and autistic children over-imitated relatively consistently across the trials, whereas there was a very low number of trials in the Fragile X group of participants who continued to over-imitate. They would only tended to do so once or twice. We didn't find any evidence of differences in the rationality discrimination trials, so I can't really comment on them at the moment. But we did find differences in the number of memory trials that groups passed on average. So the typically developing and autistic children seem to consistently pass a high number of memory trials. And this might suggest that out of the children who didn't over-imitate, they weren't doing so because of memory issues. Whereas perhaps in the Fragile X and CDS group who showed much lower levels of performance, this might have an influence. There also seems to be a suggestion that this difficulty is more prominent in the Fragile X group, as there was no sort of improvement out of those participants who over-imitated. So there might be an influence of working memory in these groups, but the nature of this relationship is unclear, and we need some more data to be able to unpick that. Another alternative is perhaps attention difficulties. So perhaps children were over-imitating on the first trial, but then not imitating on the later trials because they lost attention. However, if you look at the raw data, we see that actually very few children over-imitated on that first trial. So it doesn't seem to be a difficulty with attention, but perhaps more to do with working memory. So our findings indicate that there's evidence that children with Fragile X syndrome show different patterns of performance, and they show this interesting patterns that indicate that those with Fragile X do over-imitate, and they can, but they don't do so over repeated trials. And so similar to the role of potential attention on gaze following, it might be that difficulties in imitation in Fragile X may be mediated by this broader documented difficulties in working memory relative to their receptive language. This relationship is distinct from the autistic group, who showed lower performance but no working memory difficulties, and might need to be considered in intervention, these differences.
Hi, everyone. My name is Jane Roberts, and I'm very excited to be the discussant for this symposium. Really want to thank all the presenters for their outstanding talks and for just asking really important questions. Also want to acknowledge that this pre-recording makes it a little difficult for everyone, but I feel sort of acutely aware of how it's difficult to serve as a discussant without sort of being there in person, because I think that's one of the most exciting aspects of being able to share some thoughts about this work. So forgive me as I work through this. I know I'm among friends, and so that's great. So this symposium overall was really focused on, as the title says, on novel approaches to behavioral phenotype research in genetic syndromes associated with intellectual disabilities. I think, you know, I want to thank Jane Waite for organizing the symposium and chairing it, and really because it gives an opportunity to focus on such important topics. And so again, really honored to be a part of this. So first of all, just really want to give a shout out to the fact that this series of talks has clearly identified the importance of theory. After all, the name of this conference is the Gatlinburg Conference on Research and Theory in Intellectual and Developmental Disabilities. However, we sometimes lose track of the importance of theory and its value in driving our work. It's just absolutely critical. It's one of the very first steps to the kind of work we do in terms of driving and framing our research questions, heavily influencing the methods that we use, and really acknowledging the iterative process that, you know, happens when we look at our data and sort of go back and test whether it aligns with the theories that drove the conceptualization. So I really want to sort of hats off to this group for really sort of starting off with recognizing that value that sometimes, me included, sometimes don't articulate quite as clearly as we should. So, you know, for example, if, you know, theoretical frameworks recognize a biobehavioral approach, then our aims will recognize those, and then the methods are going to include different elements of biology that drive that behavior. And again, the data will either reinforce the appropriateness of the theory or maybe, you know, drive us to sort of update or revise it. So I think actually the study by Georgie Agar really attests to the value of this approach, which is testing operant theory. And their work really showed that the variability in sleep proximity challenges this theory and doesn't fully account for all the results. So that's one example of how this series of talks has really kind of spoke out on the importance of theory. The symposium also recognizes the deep and critical importance of developmental processes. And again, the name of this conference is Developmental Disabilities. So there's a number of talks in this specific symposium that really recognize the importance of development, including careful matching across multiple groups, especially the study by Stacey Bissell that really showed us the importance of thinking about behavioral comparisons and how important matching groups really is to be able to address questions about the primary aims. Another real value of the symposium is its inclusion of a multimodal approach and really incorporating multiple indices. And this can be seen very evidently in the work presented by Hayley Crawford, which demonstrated that common genetic variation may contribute to the variability that was observed in challenging and repetitive behaviors in their sample of males with Fragile X. And likewise, the study presented by Joanna Moss also brings home the important point of looking at variation across groups, as their initial work showed that autism and Fragile X may differ from autism in non-syndromic groups. So really, really important in the way that they demonstrated these this focus on development. And finally, really this beautiful focus on the deep phenotyping within a developmental framework was demonstrated by the work presented by Katherine Ellis, given their findings about the importance of social motivation, which is actually very foundational to guiding treatment. So again, what I want to do is just recognize the importance of all of these studies, not only individually in advancing the work that they discussed, but also collectively, and just really identifying the importance of these elements in their design in terms of really having a theoretical grounding and incorporating multi-method approach within a developmental framework. And in this era of big data, I think that's really important to not lose sight of the fact that big data can be represented across a number of facets. You know, the data could be a mile wide and an inch deep, or an inch deep and a mile, I'm about to say the same thing, or an inch wide and a mile deep. I think that when we have these rare syndromes that present challenges in recruitment and challenges in adapting data collection methods, that the inch wide and a mile deep approach and looking at multiple indices is really valuable. I guess the last point I want to end with is to just really have a sort of, I guess, a shout out in some ways to the importance of descriptive data. I think sometimes in the field, and I know, and for my own students, sometimes there's a reluctance to just describe variation within a group, or look at scatter plots, or look at, correlations. When in reality, I think sometimes those are those are the very, very important data that we really want to look at and understand. Because even though we find group differences or within group variation, it all boils down to an individual and what that individual profile is like and how that drives treatment. So again, while there's tremendous value in within group and across group variation and very sophisticated analytic techniques that can provide critical answers to many of our questions, there's also just sort of a fundamental value that in just core descriptives and getting at that individual value level. So again, thank you for your time and for your attention, and I wish you well, and I hope we can see each other in person next year. I really miss seeing everybody, and hope you're doing well. Take care.